Hello guys, let's talk about limiting reactants. But before we jump into chemistry, let's make some hamburgers with double patties. So I have a recipe right here which calls for one hamburger bun, two patties, and one slice of cheese to make a really tasty hamburger. Now, in my kitchen, I have 12 patties, 12 slices of cheese, and 8 hamburger buns. So how many cheeseburgers can I prepare? Well, let's write that information down here. So I have 8 buns, I have 12 patties, and 12 slices of cheese. So out of each, if I would use 12 slices of cheese, since for each hamburger I only need one slice of cheese, I could make 12 hamburgers. Now, if I have 12 patties, since for each cheeseburger I need 2 patties, I could just make 6 hamburgers. And if I have 8 buns in my kitchen, since for each hamburger I only need one bun, I could prepare 8 hamburgers. Okay, so which ingredient will I run out first when I am making hamburgers in my kitchen? The patties, right? Even though I have 12 of those, I will be able to only make 6 hamburgers based on the recipe given to me. So this means that the patties are my limiting ingredients. In chemistry, this is called limiting reactant. So the ingredient of which you run out first. And if you make your 6 hamburgers, you are going to still have 6 pieces of cheese left and 2 patties left. Maybe you can make some other food with that. Okay, let's move this into an example from chemistry. So we have our reaction where we react hydrogen gas with oxygen gas, forming water. And the question is, how many moles of water can we form if we have 8 moles of O2 and 10 moles of H2? So which one of the reactants, H2 or O2, will I run out first? Well, let's look at the mole ratios. So if I have 1 mole of oxygen, right? 1 mole of oxygen, I can prepare 2 moles of water. Okay? So if I have 8 mole of O2, I can prepare 16 moles of water. Now, how about H2? The ratio is 2 to 2. So this means that for each mole of oxygen gas, I will need to use up 2 moles of hydrogen gas to prepare the same amount of moles of water as hydrogen gas because the ratio is 2 to 2. So if I have 10 moles of H2, I can prepare 10 moles of H2O. So because I can prepare less moles of H2O using hydrogen gas, this is going to be the reactant of which I run out first. So this also means that H2 is going to be called my limiting reactant. Okay, now let me prove you that I will run out of hydrogen gas first in another way. Let's calculate how many moles of O2 would we need to use up all the H2 that we are given. So we are given 10 moles of H2 gas and we want to calculate how many moles of O2 do we need. So I'm converting from moles of H2 into moles of O2 using the coefficients from the reaction. So I can see that next to H2 I have a 2 and next to O2 I have a 1. So this means that 10 divided by 2, I only need 5 moles of O2 to use up all the 10 moles of H2 that is given. Okay, let's do another example. So, how many grams of ammonia or NH3 can be formed using 14.5 grams of N2 and 8.9 grams of H2 gas? Notice that in this case, not the moles are given, but actually the grams. So I can use the grams of my reactants of N2 and H2 to calculate the grams of ammonia that I am forming. Whichever is going to give me the smaller amount is going to be my limiting reactant. Okay, so let's start with N2. If I have 14.5 grams of N2, I have to convert the grams of N2 first into moles of N2. So grams of N2 are on the bottom. Moles of N2 are on the top. 1 mole of N2 actually weighs 28.01 grams. So now I have the moles of N2. I have to convert the moles of N2 into the moles of ammonia, right? Moles of NH3. In the reaction, I can see that the ratio is 1 to 2. So 1 to 2. And because I need the grams of ammonia, I have to convert the moles of ammonia NH3 into the grams of NH3. And if you calculate the molar mass, you are going to get that 1 mole of ammonia weighs 17.03 grams. Now, if you do the calculation, let's check the units. Grams of N2 cancel out, moles of N2 cancel out, moles of NH3 cancel out. So I'm going to get grams at the end of ammonia, and it is 17.6 grams. Okay, let's do the same calculation for hydrogen gas. Okay, what do you think? Which one will be the limiting, N2 or H2? Let's see. So 8.9 grams of H2. I'm converting again the grams of H2 into moles of H2. So 1 mole is 2.02 grams. Again, this is just the molar mass. And then I have to go from the moles of H2 into the moles of ammonia, NH3, from the reaction. So I need 3 moles of H2 and I can make 2 moles of ammonia, so 3 to 2. And now I have to convert the moles of ammonia into grams of ammonia. So again, 1 mole is just 17.03 grams, and that is the molar mass. Now, if you do this calculation, you are going to get 50.0 grams of NH3. Significantly more than the 17.6 that you would get if you use up all the N2 gas. So which one is my limiting reactant? The nitrogen gas is going to be my limiting reactant because I can make less amount of the product if I use up all the nitrogen gas. I'm going to end up having leftover hydrogen gas, right? So N2 is my limiting reactant. And the answer for this question is 17.6. Okay, I hope this makes sense. See you in the next video.